So welcome to the session on Max on vector calculus. So here we are going to deal of calculus of vectors. So the first thing we need to understand is what do you mean by vectors. Vectors, as we know, are quantities having both magnitude and direction. Correct? This is this. So first we need to understand two basic terminologies, that is what do you mean by dot product and what do you mean by cross product. These are two important terminologies which we are going to use very much. So a dot product is also called as a scalar product. Okay, a dot product of two vectors is what you are going to say. Say for example, A is one vector, this dot B vector, this is what is called a dot product. Now why we were interested in doing this? The formula, if you go by the formula, it is mod A mod B cos theta. See, A is a vector, B is a vector, whereas the result is a scalar. Please remember it. That means it's a number. A and B are not numbers, A and B are vectors, whereas the result is a scalar. Okay, now why I am interested in doing this is, let me say that this is my A vector, this is my B vector. I want to know the projection of B vector on A vector, that is the projection. Projection means what? In common language, it is shadow casted by B on A, or in technical language it means component of B vector along A vector is what we are trying to find. So that is this is the angle theta. Now when I project it, what will I get? I will be getting this. I will be getting this. This is the image of B on A vector. Correct? Now how dot product is going to give me? What is this? This distance by basic triangle, that is basic trigonometry, is nothing but by using the basic geometries and the concepts of trigonometry. This, if I call this as OPQ, OP is nothing but OQ cos theta. Correct? That is nothing but that is mod B cos theta. Mod B cos theta is nothing but mod A mod B cos theta divided by mod A. That is nothing but A vector dot B vector divided by modulus of A vector. So this modulus of A vector, whatever I am dividing, is just a number. This is the actual component. Correct? So A vector dot B vector can give me projection. That is, by knowing the A vector dot B vector, I can find the projection of B on the vector A. Similarly, if there is some other vector called C, if I do C vector dot B vector by mod C, I will get projection of that on projection of B vector on C vector. So dot product is ultimately going to give me projection, that is nothing but the component of B along A. This is very important. Okay. Now let us come to the story of cross product. So what do you mean by cross product? Cross product is A vector cross B vector. The result is going to be another vector. So the source is also vector, the result is also a vector. This is very important. That means C is going to have a direction. See, here the result is a scalar. So when you say scalar, the scalar will not have any direction, whereas C vector is the result of A and B cross product. That means C will have a direction. Okay. Now the relation of A cross B is given by A B sin theta n hat, where n hat is the unit normal vector to the plane containing A vector and B vector. Or also I can write A vector cross B vector as I, J, K. If A1, A2, A3 are the components of A vector, B1, B2, B3 are the components of B vector, it can be written like this. That is, my A vector is nothing but A1i plus A2j plus A3k. Similarly, my B vector is nothing but B1i plus B2j plus B3k vector. Now understand that A vector cross B vector is perpendicular to both A vector and B vector. Please remember this. This is very, very important, because clearly it is told that n hat is the unit normal vector perpendicular to the plane, unit normal vector to the plane containing A vector and B vector. That is, normal is always perpendicular, correct? So there is a plane which contains A and B. So the n hat is in the direction which is normal to the plane. That means it is perpendicular to all the vectors contained in the plane. That means it is perpendicular to A vector and B vector also. Clear? Now what is the meaning of A cross B? This is very important. The thing, what is going to be A cross B is nothing but rotation. It is going to give you the rotation potential or the torque. In other words, in pure mechanical terms, I have to say it is going to give you the torque. Now, one more important thing you have to remember, since A cross B is a vector, the direction of A cross B, magnitude of A cross B will be same as magnitude of B cross A. But direction of A cross B is not equal to direction of B cross A. Both are in opposite direction. Therefore, on general basis, I can say A cross B is not equal to B cross A. So, these are the basics which are very important for proceeding ahead in vector calculus. Clear? Fine. Next important thing we are going to see is the vector differential operator. It is called the del. It is a vector I dou by dou x plus j vector times dou by dou y plus k vector times dou by dou z. See, it is not a vector as what we say like a vector or a B vector, which is a1i plus b1j, a1i plus a2j plus a3k. It's not a vector. Del is not a vector like this. Say for example, I have a vector called a1i plus a2j plus a3k. These are numbers. A1, A2, A3 are numbers which are weighting the I vector, J vector, K vector along the respective directions. So we get a vector A. This del is not this type. Del is a operator. It is not a general vector where you can quantify it. Del is a operator. So as such, del has no meaning. Only when you operate it on some scalar or vector, then it gives you a meaning. Okay. As such, del has no meaning. As such, del has no meaning because it's an operator. See, if I say what is the meaning of plus? Plus will have meaning only when you put one number before that. See, if I write simply plus, it has no meaning. Only when you write 3 plus 5, then it has meaning, because this is a number, it is being operated by this plus to give you this result. As such, plus has no meaning. Correct? As long as you don't know what is sitting here and what is sitting here. Correct? So, as such, del has no meaning. It has to be supplied with some operands. Then only it will have meaning. Clear? Okay. Now, the first operation we are going to see is called the gradient. Gradient is always calculated for scalar fields. So, let phi be a scalar field. Scalar field in the sense scalar function. Okay, as such in mathematical term it is a scalar function. And then I define gradient of phi. I write it as grade phi. Grade phi as del phi. The result will be a vector. Please remember that phi is scalar, whereas del phi is a vector. See, it is del is a vector, phi is a scalar. Now you are scaling the vector del by phi. That's what it means. That is, you are operating del with phi. I'm sorry, you are operating phi with del, because del is the operator, right? Sorry, I told it in the reverse way. Okay, fine. Now please remember, del dot phi or del cross phi are meaningless. Please remember these things, because whenever you take a dot product, you are allowed to take a vector dot b vector only. You cannot take a vector dot b. This is wrong. Similarly, for cross product also you have only a cross b. You cannot do a cross b, which is a scalar. This is meaningless. Similarly, del is a vector. So del dot phi is a scalar. Del dot phi and del cross phi are meaningless. Only you can do del phi. Clear? Del phi means what? That is, del is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z of phi. It's nothing but I vector times dou phi by dou x plus j vector times dou phi by dou y plus k vector times dou phi by dou z. This is what is called grade phi or gradient of phi. Now what is the meaning of that? Now I have understood del, but what is the meaning? Ultimately, why I am doing it? This is very important. The meaning is, del phi is giving the variation of scalar function phi along its normal. That is, along the normal to the phi at that point. Now what is the use of this? The use is, we can find variation of phi along any direction at that point by projecting del phi on that direction. So it might, like I have told many things in English here, we will see it in a pictorial form. It will be very helpful. So I will just read out what I have written. Del phi is giving the variation of the scalar function phi along its normal at that point. We can find variation of phi along any direction at that point by projecting del phi on that direction. We will see the meaning of this in the next. Okay, let me take a scalar function like this. Let me take, say this is some surface. Okay, so this is a point. So the normal to this point will be in the, say this is the normal. Say this point, let me call this as P. So this vector, let me call this as k vector, the normal vector. Okay, let me not take k. Let me take it as n vector, because k means there is also another k, you should not get confused. So this is the normal vector. Now, okay, this is phi, this function is phi. Now del phi is giving variation of phi, or rather del phi, I will put it like this, del phi at point P is giving variation of phi along n vector. What is n vector? Normal to phi at P. Okay, see, I am evaluating del phi at point P. So at point P, n vector is the normal vector. And del phi is going to give me the variation of phi along the n vector. Now let me say there is some m vector in this direction. What is the way? Now if you know the variation along normal, you want to know what is the variation of this phi along the direction of m, you simply project this on m. So this will be the variation of phi along m. So variation along any direction can be calculated. Can be calculated by projection of del phi, correct? Yes or no? At that point, now if I don't put any point, I will get del phi as a function. Then at every point, by substituting that corresponding value of that point, the coordinate value of that point, I will know the variation at each and every point. And at each and every point, I know the variation along normal. I can find the variation along any direction given the point. Clear? Is this clear? Okay. I repeat, if I don't substitute, see here I am evaluating at point P. That is, you will be first finding del phi and you will be substituting for the point P. So you will get del phi as a vector, not as a function. And then you will project that vector on this vector to find what is the variation along m. Now if I don't substitute the value of point P, you will get del phi as a function. Now instead of P, you want to find it at Q, you substitute the xyz value of Q. Now it will give the variation along the normal to Q. Now you can find the variation, say for example, let me call this as nq vector. You can find the variation of along mq vector by projecting the normal here. Clear? This is what we are going to do. Now let us solve problems. When we solve problems, it will be more clear. So let us solve problems now. The first thing we are going to solve is, let phi and psi be two scalar functions. What is the value of del phi psi? So what we are asked is, phi comma psi are scalar functions. Now what we are asked is del of phi psi, means what? Gradient of phi psi. Now what is this dot? This dot is not dot product. Please remember that. Because dot product can be taken between only two vectors. But phi and psi are scalars. Remember that, okay? This is very important. So this dot is just a multiplication. Like how I write 5 into 2 as 5.2, like that only it is. Okay, now let me write the meaning of it. If I expand this, what will I get? I vector times dou by dou x plus j vector times dou by dou y plus k vector times dou by dou z of phi psi. Now I can operate it now. If I operate it, what will I get? I vector times dou phi psi by dou x plus j vector times dou phi psi by dou y plus k vector times dou phi psi by dou z. Now we have to solve this. Now if I recollect from the basics of differentiation, what is differentiation of uv? D by dx of uv is what? It's nothing but u dv plus v du, product rule, right? Product rule. So if I use the same thing here, what will I get? Phi and psi are two functions. So this can be written as what? Phi times I vector is separately outside. Phi times dou psi by dou x plus psi times dou phi by dou x plus j vector phi times dou psi by dou y plus psi times dou phi by dou y plus k vector times phi, I'm sorry, dou psi by dou x plus I times dou phi by dou z. Now if I group the I, j, k terms, what will I get? I can simplify this and write it as phi into, see there is one phi term here, there is one phi term here, there is one phi term here. These are scalars, right? I can take it out. So if I write it out, what will I get? Phi times I dou psi by dou x plus j times j vector dou psi by dou y plus k vector dou psi by dou z plus phi. Similarly, phi I have here, here and here. I can group them. Psi times dou phi I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. So this is nothing but what? Phi times, this is nothing but what? Grade psi, right? So del psi plus psi times del phi. This is what it is. So this is a very important result. Please remember. Gradient of phi psi is nothing but phi gradient of psi plus psi gradient of phi, where phi and psi are scalar functions. Clear? Now, as we saw in the previous page, so the meaning of del phi, what is the del phi can be used for? Del phi can be used to find variation of phi along any direction by projecting del phi on that vector, correct, on that vector. What is this vector? This is that vector which is describing this direction, correct. This is the vector which is describing this direction. Okay, that's what it is. Now this variation along any direction is called directional derivative. It is called mathematically as directional derivative. Okay, so ultimately if you are asked to find directional derivative, what you have to find del phi and find projection of del phi on the given vector. That's what we have to do. Okay, let us solve a quick example related to this. It will be more interesting. Find the directional derivative of phi, which is a scalar function given by x square yz plus 4xz square plus xyz at point 1, 2, 3 along 2I plus j minus k. This is what is told. So first thing is we have to find, so the solution is this way. Find del phi at given point and project it on the given vector. Okay, this is what we are going to do. So phi is given. So what is del phi? Del phi is nothing but I dou by dou x plus j vector dou by dou y plus k vector dou by dou z operator on phi. So it's nothing but what is phi here? Phi is given to be what? I vector dou by dou x times what is 5 here? X square yz plus 4xz square plus xyz plus j vector times dou by dou y of x square yz plus 4xz square plus xyz plus k vector dou by dou z x square yz plus 4xz square plus xyz. So on differentiation we are going to do partial differentiation. So what we will get? I vector times dou by dou x of this. So what will be dou by dou x? X square, y and z are constant when I am going to do partial differentiation with respect to x. So this part will give me 2xyz plus 4z square plus yz. Correct? Plus j vector times, here I am going to do dou by dou y. So x and z are constants for me. So this will give me x square z plus 4xz square will give me 0 because there is no y term, plus xz plus k vector times, what will I get? X square, x and y are constant because I am going to do partial differentiation with respect to z. So this will be x square y plus xz square means I will get it as 8xz plus xy. So this is what is del phi. This is generally a function. Now this is a function which is giving you the variation of the of the given scalar function along the normal. Along normal means what? There is no point. This is the variation to the normal to the entire surface. Now when I put the point, automatically it will give me the variation of the function phi along the normal at that point. That is very important. Clear? So del phi at 1, 2, 3 is what? That is what we have to calculate. Now you substitute for x as 1, y as 2, z as 3. So del phi will be what? If you substitute, what you will get? 2 into 1 into 2 into 3, like that. When we substitute everywhere, 1 as x, 2 as y, 3 as z, we will be getting del phi as 54 I vector plus 6j vector plus 28k vector. This is what we will be getting, 28k vector. Now we have to find the directional derivative. Directional derivative, in short I will write it as dd. Directional derivative, in short I will write it as dd. So dd is nothing but what? Del phi dot given vector divided by modulus of given vector. That is what it is. So along which direction we are asked? 2y plus j minus k. This is the direction we are asked. So we are going to project on that. That is nothing but 54i plus 6j plus 28k dot 2i plus j minus k by modulus. How will you calculate mod of a vector? It's nothing but x a square plus b square plus, that is the component along the I square, root of the component along I square plus component along j square plus component along k square. So that is nothing but 2 square plus 1 square plus minus 1 the whole square. This is nothing but, when you take the dot product, how will you take dot product? We will take the corresponding terms. So this is nothing but 54 into 2 plus 6 into 1 minus 6 into 1 minus 28 into 1 divided by root of 4 root 6 you will get, right? Root 6. So the final answer will be what? 54 108 minus 28 plus 6 is 86. 86 divided by root 6. This is the answer. This is the answer. 86 by root 6 is the variation of del phi, where phi is given by like this, at point 1 comma 2 comma 3 along this. So the answer is 86 by root 6. This is the answer. Okay. Now this is another interesting question. Find a unit normal vector to the surface x square y plus 2xz square minus 8 equal to 0 at 1 comma 0 comma 2. This is what is asked. Okay. So ultimately what we have to find, this is a very important. See, if you are asked to find a normal vector, see, del phi is normal to phi at given point, at that point. But we are not asked to find a normal vector, we are asked to find a unit normal vector. So how will you make the vector as a unit normal vector? Nothing. Del phi divided by mod of del phi. That's what we have to do. Clear? So find del phi divided by mod of del phi at that point. That's what is the answer. So what is del phi? Del phi is nothing but, for the given vector, it is nothing but dou by dou x times x square y plus 2xz square minus 8 plus j vector times dou by dou y of x square y plus 2xz square minus 8 plus k dou by dou z of x square y plus 2xz square minus 8. So when you simplify this, what we will get? We will get this as I vector times 2xy plus 2z square plus j vector times, here x and z are constant, so we will be getting it as x square plus x square, that's it, plus 0 you will be getting because there is no y term here, plus k vector times dou by dou z of x square y will give you 0 because there are no z terms, and 2xz square will give me 4xz. That's it. This is the value of del phi. Now at 1 comma 0 comma 2, del phi will be what? We have to substitute these values. So this will be, when we substitute the values, it will be what? 8i, this is the value of x, y and z. So it will give me 8i, because this term will become 0. This is 2 into 2 into 2, 8i plus j plus 4xz will give me 4 into 1 into 2, that is 8k vector. So this is the value of del phi. This is the value of del phi. Now how will you find the unit normal vector? Unit normal vector is nothing but, whenever you are asked to find the unit vector, it is nothing but, see, if you have a vector called a vector, you have to find the unit vector along a vector is nothing but a vector divided by modulus of a. Similarly, here we have to find del phi divided by modulus of del phi, that is nothing but 8i plus j plus 8k divided by root of 8 square plus 1 square plus 8 square, that is nothing but 8i plus j plus 8k divided by root 129. This is the answer. Okay. Now let us solve one more problem. This is another interesting one. Let me take a new page for this. So this is the question. The question is find the angle between the surfaces x square plus y square minus z minus 3 equal to 0 and x square plus y square plus z square minus 9 equal to 0 at 2 comma minus 1 comma 2. See, this is a very interesting problem. So here you have to understand one thing. You have a surface here, okay, and you have another surface. This is surface S1, this is surface S2. At some point you are asked to find what is the angle between these two surfaces. Remember that the angle between these two surfaces is nothing but angle between two surfaces is nothing but angle between normal to that surface. Okay, to illustrate, let us see it in terms of simple planes. Say this is one plane, okay, and this is another plane. The normal will be here in this direction. Here the normal will be here. Clearly it is visible that these two planes are 90 degree. The angle between them is also 90 degree. See that. This angle is same as this angle. Correct? These two angles will always be same. So angle between two surfaces is nothing but angle between normal to that surface. Please remember that. This is very, very important point. Now, so that is, there is one normal here. Rather it is something like we are evaluating at that point, right? So the normal to this surface here will be in this direction. The normal to S2 will be in this direction. This angle is same as this angle now. Correct? Yes or no? So angle between surfaces, say this is the normal to NS2, NS1. The angle between the normal to the surfaces is nothing but the angle between the surfaces itself. Now how to find normal? How to find normal? Del phi. Correct? Del phi will give me. So let me take this as phi 1 and let me take this as phi 2. Okay, where S1 is nothing but phi 1, S2 is nothing but phi 2. Correct? Now I have found the angle between. Now I have found del phi 1, del phi 2. How will I find the angle between that? I know. Say for example, if I have two vectors called A vector, B vector, if I take the dot product of them, what it will give me? AB cos theta. So from this, how can I find cos theta? A vector dot B vector divided by mod of A into mod of B. So theta is nothing but cos inverse of A vector dot B vector divided by mod A into mod B. Correct? So where theta is the angle between the surface. Correct? Theta is nothing but angle between A and B. So now what we are going to do? Del phi 1 is gradient of phi 1, that is normal to phi 1. Del phi 2 is gradient phi 2, that is normal to phi 2. Now angle between normal is nothing but angle between surfaces. So we are ultimately it is the finding the angle between del phi 1 and del phi 2. So angle between del phi 1, let this be theta. Let theta be angle between phi 1 and phi 2. Implies theta will be angle between normals also. So del phi 1 and angle between del phi 1 and del phi 2 also, because angle between the surfaces is nothing but the angle between the normal to the surfaces. We have seen it, right? So ultimately theta is nothing but cos inverse of del phi 1 dot del phi 2 divided by del phi 1 del phi 2. That's it. This is the answer. Ultimately we have to find these things and plug in these values here. We will get the answer in. Correct? So we know what is phi 1, we know what is phi 2. From that we can find, if I know this and this, I can find this and this at that given point. Correct? 2 comma minus 1 comma 2, which is the given point. Correct? So what is del phi 1? Del phi 1 is nothing but what? I have to find I vector times dou by dou x of x square plus y square minus z minus 3 plus j vector times dou by dou y of x square plus y square minus z minus 3 plus k vector times dou by dou z of x square plus y square minus z minus 3. So del phi 1 will be what? I vector times 2x plus j vector times 2y plus k vector times minus 1. Correct? So at 2 comma minus 1 comma 2, del phi 1 is nothing but what? What is del phi 1? It will be nothing but 4i minus 2j minus 2j minus k, right? It will be minus k, because k is not having any term, it is just minus 1k, it's independent of x, y, z. 4i minus 2j minus k vector. This is what we will get. Clear? Okay. Now we have to find del phi 2. What is del phi 2? It is nothing but I vector dou by dou x of x square plus y square minus x square plus y square plus z square minus 9 plus j vector dou by dou y of x square plus y square plus z square minus 9 plus k vector dou by dou z of x square plus y square plus z square minus 9. So if I simplify this, what will I get? It is nothing but I vector times, I will get dou by this 2x plus j vector times 2y plus k vector times 2z. This is what I will get as del phi 2. So at 2 comma minus 1 comma 2, del phi 2 is nothing but plus 4i minus 2j plus, here it is dependent on z, so plus 4k. Correct? This is what we will get. So now find theta. What is theta? Theta is nothing but cos inverse of del phi 1 dot del phi 2 divided by modulus of del phi 1 modulus of del phi 2. So this is nothing but cos inverse of del phi 1 is what? We calculated it, right? Del phi 1 is nothing but 4i minus 2j minus k vector dot del phi 2 is 4i minus 2j plus 4k divided by determinant of modulus of this, 4 square plus minus 2 square plus minus 1 square into root of 4 square plus minus 2 square plus 4 square. This is what it is. So on simplification it will give me cos inverse of 4 into 4 16 plus 4 minus 4 divided by root of 16 plus 4 root 21 into root 36. There is nothing but cos inverse of 16 by root 36 is nothing but 6 root 21 This can be simplified as 8 3. So theta is nothing but cos inverse of 8 by 3 root 21. This is the answer. Clear? Now please be careful between the radian and the degrees mode when you are using these type of things. Okay, that is very important. Please observe whether the answer is given in radians or degrees. Accordingly you have to report the answer. Clear? Fine. Okay, this one is another interesting problem. Now we are going to solve one more problem. Here del phi is given to you. You are asked to find phi. Del phi is equal to yz I vector plus xz j vector plus xy k vector. Find phi. This is what is asked. This is another interesting problem. So by definition, what is del phi? Del phi is nothing but I times dou phi by dou x plus j times dou phi by dou y plus k times dou phi by dou z. Okay, so this value is what is sitting here, this value is what is sitting here, and this value is what is sitting here. Clear? So the moment del phi is given, we know that dou phi by dou x is nothing but yz. Dou phi by dou y is nothing but xz. Dou phi by dou z is nothing but xy. Now I have to integrate this. Correct. See, dou phi by dou x is yz. So dou phi is nothing but yz dot dou x. So if I integrate this, I will get phi. Now one thing you have to understand here. This is dou x, it's not dx. This is not dx, it is dou x. That means what? Now this problem is simple in one angle, but it is equally complicated in some other direction. We have to pay careful attention here. Let me take a new page for that. Okay, let me little bit digress from the problem and give you one small illustration. Okay, let me take some other scalar called lambda. Let lambda, this is just an illustration. Okay, let lambda equal to xy plus y. Let me take this as lambda 1. Let me take some other thing called lambda 2, which is xy plus 3. Okay. Now, what is dou lambda 1 by dou x? It is x. I'm sorry. It is y. It is y, not x. That is xy. X is y is a constant. X on differentiation will give me y. This y on differentiation will give me partially with respect to x will give me 0. Dou lambda 2 by dou x is what? This will also give me y plus 0. So this is also y. This is also y. Now, if I have to find what is lambda by looking at this, if I have to find what is lambda by looking into this, how will you find? Dou lambda 1 is nothing but y dou x. So lambda 1 is nothing but integral of dou lambda 1. This is nothing but y integral of y dou x. There is nothing but xy plus something. Okay. Now let us do the same thing here. Lambda 2 is nothing but integral of dou lambda 2. That is nothing but integral of y dou x. This is also nothing but xy plus c. Now, Pay attention, look at lambda here. Lambda is y. Since I partially differentiated lambda, I don't know whether this constant is really a constant like 3 or a term which is not containing x like y. So we don't know. See, this constant and this constant are not same. This constant is a number, that is 3, whereas this constant is a function not containing x term. Because this constant is not 3, it's not a number, it is a term called y, which is another component of this function, but it is not containing x term. So when we are doing partial integrations, we have to be very careful. We don't know whether the number is the constant is really a number or a constant is a function which is not containing the corresponding term. We have to be really very careful on this point. So whenever we do partial integration, we always assume the constant to be a function not containing the corresponding variable. Is this clear? This is a very important concept you have to remember. Later we will substitute we will evaluate the constant. Later evaluate the constant. Clear? So now let us go back to the problem. We had dou phi by dou x to be, now we are coming back to the problem. We found that dou phi by dou x is nothing but yz, dou phi by dou y is nothing but xz, dou phi by dou z is nothing but xy. Now when we integrate this, phi is nothing but integral of dou phi, that is nothing but integral of yz dou x, this is nothing but xyz plus, what is this? Now this is going to be a constant. What is this constant now? This constant can be a function not containing x, correct? Function not containing x means it can be a function of y comma z, purely a y and z term. We don't know, correct? Now go to display dou phi by dou y. What we will get? Phi is nothing but integral of dou phi, it is nothing but integral of xz dou y. What we will get here? This is again when we do partial integration, we will get xyz plus, here it can be a function not containing y. That means it can be a function of x and z. We don't know. It might be a constant also, it might be a function containing xz also. We don't know. It is better to assume this as a function and later prove that this function is a constant. Now from this, what is phi? Phi is nothing but integral of dou phi. It is nothing but integral of xy dou z. What is this? This is nothing but xyz plus function of x comma y. We don't know. This might be a constant or it can be a function of x and y. We have to evaluate it. So if I see, but all these three phi's are same. But all these three phi's are same. Correct? Yes or no? All these three phi's are same. Because we have evaluated the same thing here, correct? That means what we are going to do is, what is phi? Phi is going to be xyz plus a function. Let me write this clearly here. Phi is nothing but xyz plus function of yz. It can be a function not containing this, but a function not involving x, function not involving y, function not involving z. Function of xy means what? Function not containing z. Here this is nothing but function not containing y. This is nothing but function not containing x. That means this part is nothing but a function not containing x, not containing y, not containing z. Therefore this part has to be a constant. Here we conclude it. This is how it has to be done. And therefore phi is nothing but xyz plus constant is a solution. Why? How we are concluding it's a constant? From this, that is from 1, we can say that this part is a constant. The part which is remaining is a constant which is not containing x. From the other part we see that it's a, see, if I equate this phi and this phi are the same phi's, correct? That means xyz plus a function not containing x should be equal to xyz plus function not containing y should be equal to xyz plus function not containing z. All the three are same. That means if I try to evaluate the coefficient of x, it should be there. If there is some x term here, there has to be some other x term here also. But here there are no x terms. But here you are saying that there can be x term, there can be x term. Here there is no y term. Here there is no y term. You are saying that here and here there can be y terms. Here there is no z. Here and here. But all the three are same. That means that has to be a constant. You cannot say that you don't have a z term here and you have a z term in 2, you don't have a z term in 3, but you have in 1 and 2. That means 1 and 2 cannot be equal to 3. Correct? So if 1 equal to 2 equal to 3, the only way is the remaining part has to be a constant. Because all the three are evaluated for the same phi. Clear? This is very important. Please remember this. Okay. Thank you.